Hello everyone. In today's video, we're going to be covering dependency inversion, which is a fairly abstract concept to think about. So in this video, I'm going to simplify it and give you concrete examples of dependency inversion so you will understand it in depth by the end of this video. Let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream projects sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this one. Now to get started, I want to talk about the abstract concept of what the dependency inversion principle is by using a concrete example. And right now we have an application that allows users to buy different things from our store. So we have some form of store over here on the left-hand side, which is calling out to the Stripe API in order to handle all of the credit card information and user payment processing. So what this is saying is our store depends on the Stripe API. And inside of our code, we have exact lines that say like stripe.makepayment or stripe.checkcreditcard inside of our store code. So our store is very coupled to our Stripe API. It calls it directly. And this is a little bit of a problem because what happens if we want to test our code very easily? We have to make all of these calls to the Stripe API, and we don't want to call the Stripe API while we're testing. Also, what if we want to switch to PayPal or allow them to pay with PayPal on top of Stripe? Adding that in means we have to change tons and tons of code in our store, swap out all that Stripe code, and put in all of this PayPal code. So what happens in the dependency inversion principle is that you add in a piece in the middle, kind of an interface, which contains all of the behavior that we want our API to be able to do. So we implement this payment processor. And now our store calls the payment processor and says payment processor.checkcreditcard or payment processor.makepayment, whatever it is. And this payment processor doesn't depend on anything. It's just an API. It's just a bunch of functions that we can call like check credit card, do this, do that, make payment. It doesn't matter what it is, but it's just an idea of what we can do. And then we have a specific implementation. So we have our Stripe implementation of our payment processor. And now we can just plug our Stripe implementation into our store. We give our store the Stripe implementation, and it'll call methods on the payment processor. But those payment processor methods will actually be calling this Stripe API since it's set up to delegate those methods to Stripe. And that Stripe interface that we created is allowing it to talk with Stripe. So what this allows us to do is to actually have two different APIs. We can create a payment processor for PayPal and a payment processor for Stripe, and they both use the same exact API, the same exact underlying functions. So our store never has to change unless we change our payment processor, which is just an abstract idea of the different types of payments that we can make. The idea of this is a lot of times referred to as like the adapter pattern or the facade pattern, where you create this wrapper essentially around external dependencies that you have. So that way your code depends on the wrapper you created and not the actual implementation of the detail for the dependency you're using. And that's the idea of dependency inversion. You do not want your high-level code, for example, this store class, this store method, whatever it is, to depend upon the low-level implementation of your dependencies. We don't want it to depend on how Stripe works or how PayPal works. We don't depend on this payment processor that wraps those functionalities, which is something that we can control and easily make Stripe and PayPal look exactly the same to our application. So if we change out Stripe, we change out PayPal, Stripe updates, PayPal updates, it doesn't matter. Nothing in our code will change inside of this store. It will remain exactly the same. So now that I've talked about what these different ideas are, let's go into a concrete code example. So here's a concrete version of that example where we have our store, we have Stripe, we have PayPal, which we'll look at it a little later, and then some implementation details actually calling that store. So let's take a look at this code in depth. We have our store, which is going to take in a user. It's going to create that new Stripe object. And this Stripe class that I'm referring to here is, you can imagine, like the actual Stripe API. I obviously don't want to use the actual Stripe API in this example. So this Stripe class here is essentially our version of the Stripe API. So just think of this as the Stripe API for these examples, and it'll make a lot of sense. So we're creating an object that allows us to access the Stripe API directly. Then we can purchase a bike and a helmet inside of this store, and we're just calling the Stripe API, making a payment, and a bike cost $200, so we're saying 200 times the price of the bike. And since Stripe always wants us to send the amount in pennies, we multiply that by 100, so then we're sending them the amount of pennies it cost to buy this bike. Same thing for helmet, except for a helmet is only $15 instead of $200. Now if we go to our Stripe class, you can see it takes in a user, which is the user we're going to make payments on, and then it's going to make that payment using the amount in pennies, like I said, and it just logs out that the user paid the amount of money they paid in dollars using Stripe. And we created a new store down here where John is going to buy 2 bikes and 2 helmets. And if we save this, you can see that since our bike cost 200 and he bought 2, John made a payment of $400 with Stripe. And then since the helmets are $15 and he bought 2, he's now made a payment of $30 with Stripe. So now let's say this is working great, everything's going well, but Stripe changes their pricing, and now Stripe is really expensive to use, so we want to switch over to PayPal, because PayPal is really cheap, it's way better for our business, so we're going to use PayPal. So now here's what the PayPal API looks like. It doesn't take in a user in the constructor, it actually takes a user in the make payment method, and it wants its amount in dollars. It doesn't take it in pennies, it takes it in dollars. And then it of course logs out the exact same thing, except for it's saying that it bought it with PayPal. So in order to use PayPal inside of our application, the first thing we need to do is to change our constructor. We have to change this to say this dot PayPal is going to equal to a new PayPal. And since PayPal doesn't take the user object, we can't send it. So we have to also create a user variable here. So this dot user equals new or equals user, just like that. Let's comment out our Stripe. And then in order to make a payment with PayPal, what we need to do is say this dot PayPal dot make payment. We want to do the price times the quantity. And we need to also make sure we pass in this dot user. And we need to do the same thing here with the helmet. So we can say this dot PayPal dot make payment, this dot user, the price times the quantity. And now if we save our code, you'll see that it's exactly the same. John made the $400 payment with PayPal and he made the $30 payment with PayPal. And that was fairly painless to change over, but you can imagine in a real application with a real store, the amount of times that you have payment code is going to be a lot. It's going to be all over the place. And also, the number of methods inside those APIs is going to be a lot more than one, and there's probably going to be a lot more differences. Luckily, we have 2 methods that both are called make payment, which allow us to easily transfer between these 2 different APIs. But you can imagine the way PayPal does payments and the way Stripe does payments are going to be very different. So making a transition like this is going to be really hard in most cases. So what you want to do instead is to create some kind of intermediate API. This is going to be your wrapper, which is going to wrap around Stripe and wrap around PayPal. And the idea of this wrapper is that it has the exact same functions, the exact same methods, the exact same interface. So in our store, we never have to change our store. So let's imagine that we have a class called payment processor, and this is just going to take in a user. So we can say here payment processor, just like that. And then our payment processor is just going to have a function called pay. And this function that's called pay is just going to take in the amount in dollars. So we'll say 200 times quantity. And we'll do the exact same thing down here, except for we want to just pass in 15 times our quantity. And we want to make sure this is the payment processor. Whoops. Payment processor dot pay. So there we go. Now we have our code using this payment processor, which always takes in a user in the constructor, and it's always going to take in the amount in dollars for a function called pay. And we want to have different payment processors, one for Stripe and one for PayPal, which wrap these dependencies of PayPal and Stripe so that we don't depend on the exact implementation of Stripe or PayPal. So let's create one first for Stripe. We're going to call this our Stripe payment processor. Whoops. And our Stripe payment processor, just like we mentioned earlier, is going to take in a user, and it's going to set the user equal to user, because this needs to match the API we created up here. it's also going to have a function called pay, which is the amount in dollars. And all we want to do is call Stripe. So up inside of our constructor, we can actually just say this.stripe is going to be equal to a new stripe. We can pass in that user, and we don't even need to save this user anymore. And down in here, we can say stripe.makePayment, and we want to make sure that we make this payment in cents. So we can say amount in dollars divided by, multiplied by 100. So now that we actually have this payment processor created, what we can do is pass this payment processor into the store. So instead of passing a user in here, we're going to pass in our payment processor, and we don't need to create a new payment processor in the store anymore. We can just set that to our payment processor. Now down inside of our store, all we need to do is pass in our new Stripe payment processor with the name of our user, for example, John. And now if we save, you see that this payment processor that we created for Stripe is passing off all of our function calls to the Stripe API down here, and you can see it's printing out the proper information on the right-hand side of the screen. And the best part is we can create another payment processor, if we just copy this, for PayPal, and all we have to do is change this single line down here where we instantiate a PayPal processor instead of a Stripe processor. So let's create that PayPal processor, just like this. And we want to first set our user. So we're going to set it to the user we got passed in. And now inside of this pay function, we want to make sure that we call that PayPal API. So we'll create the PayPal API up here, just like that. And it doesn't take in a user, as you remember. So now we can say this.paypal.makePayment, and we want the amount to be in dollars, and we want to pass in the user, just like that. And now if we save and come down here and change this to our PayPal processor, you'll see that we're getting an error, and that's just because we need to make sure we use this.user inside of our makePayment function. And now when we save, you see John is able to make that payment through PayPal and this other payment through PayPal, and we didn't have to change any of the code inside of our store. This all stayed exactly the same because we have this payment processor interface or method or abstraction, whatever you want to call it, that is allowing us to not have to change any of this code. And all we need to do is create a new payment processor, wrapping the API we want to use, and then we just pass that into the store down here. This setup is very similar to the facade pattern or the adapter pattern, which I have videos on the facade pattern you can check out. I'll link in the cards and the description down below. And that's all you need to know about the dependency inversion principle. If you enjoyed this video, make sure to check out my other solid design principle videos linked over here, and subscribe to the channel for more videos just like this one. Thank you very much for watching, and have a good day.